can I just build this intelligence layer on top of a vulnerability management program, especially if I'm an established vulnerability management program person?
Technically, you can. And there's a lot of things down the line that become tricky. Suddenly, you go from rules to reasoning. One of the security engineers in their team had built basically a few scripts in his laptop. And then the challenge became when that person tried to leave the company. If tomorrow Bedrock is down, for an LLM first company, there's no product. There is this whole discussion around how do you evaluate? And there's this wide evaluation that is, you look at the results, looks great. But this is no way of evaluating LLM systems. Well-crafted agents, it's going to be very hard to differentiate from super intelligent AI.
If you have been on a camp similar to me where you're considering whether you should build or buy AI for your vulnerability management in cloud, this is a conversation for you. I spoke to Santiago, who's a CTO at a company called Maze, and we spoke about some of the details of what does it actually take to build a AI-first vulnerability management for a cloud source. Like the real-time logs coming in, what does that mean from a cost perspective? What kind of team skill set? What are some of the components would you need to make it scalable so that you're able to run it as a whole system? All that and a lot more in this episode with Santiago. If you know someone else who's trying to build an AI-first security solution within their organization, definitely share this with them because they'll appreciate all the insights for what does it actually take to build versus buy an AI-first solution. A little hint, it's not what Sam Altman is telling you. If you're listening or watching an episode of Cloud Security Podcast for a second or third time, I would really appreciate if you take a quick second to subscribe and follow on whichever platform you're listening or watching this on, whether it's Spotify, YouTube, LinkedIn, Apple Podcast. I love all the feedback coming in the comments as well, so feel free to drop them too if that's much more easier. I appreciate the extra second you take to hit the subscribe follow because it helps us grow and find more amazing guests. I hope you enjoy this episode and I'll talk to you soon. Peace. Hello and welcome to another episode of Cloud Security Podcast. I've got Santiago with me. Hey man, thanks for coming on the show.
Glad to be here.
I was going to start with an introduction. So for people who do not know Santiago, could you share a bit about yourself, your background, where you are today?
Yeah, absolutely. I'm Santiago, co-founder and CTO at Maze. I'm based in Munich, Germany. I've been working in a few things over the last years, mainly basically data pipelines for cybersecurity data, specifically vulnerability management. Before that, I was CTO at another small startup, and I spent some time at Amazon, generally being in a few startups before that.
Awesome. And today's conversation is about the whole AI-first vulnerability management thing. I mean, obviously, AI is top of mind for a lot of people, but the one conversation that I think we were talking about this before we started the recording, I come across this in the advisory board that we run, and you're coming across this as well, the whole build versus buy conversation. But before we jump into that, I want to set the tone for the AI-first vulnerability management. What is the AI-first cloud vulnerability management, so specifically?
Yeah. So the way I think about it is traditional vulnerability management has been very heavily rule-based. So the goal for years, and basically what Synapse brought to the picture, is bringing massive amounts of data into one place, so you can do very unique rules that basically match your security posture and your, let's say, risk appetite and how you define risk and how do you value risk or evaluate risk. So I think basically AI native or LLM native changes the picture completely because suddenly you go from rules to reasoning. So this is one of the ways we describe it. And I think reasoning is very, very different because you can be very contextual. So you don't need to be specific about the parameters of a rule, but basically evaluate based on the context that you have. And I think this changes the game completely. And what I would say is like AI native would be basically products that use this reasoning as the core decision-making engine of the products.
Oh, right. So it's not just about me getting my, the way people describe it, what's my vulnerability at the moment. It's more of an intelligence layer on top of it.
Yeah, exactly. So it's basically figuring out the vulnerabilities, but then you can have a lot of understanding of the specific context where the vulnerability is and really do a more thorough assessment. So it could be from looking at, is this really a problem for us, to what is the impact, what are other assets around it, what is the likelihood, so is it something that is easy or hard to exploit, is it something that an attacker will, let's say, prefer against another type of vulnerabilities in your environment. So it's very smart, let's say, reasoning and decision making when you're looking at prioritizing and deciding what's really is important. And
actually, now that brings me to the build versus buy thing. Sounds like we're just adding AI to the vulnerability management. I'm going to, as I oversimplify this whole thing, can I just use, I don't know, man, Gemini 3, ChatGPT 5 point, whatever is out now, Can I just build this intelligence layer on top of a vulnerability management program, especially if I'm an established vulnerability management program person?
Technically, you can. There's a lot of difficulties on the way. Some of them are things that you can probably figure out if you think hard about it. And there's others that are sort of like more nuanced and that only get to understand them and understand the impact of these things along the way. So the main things that I would think about is all about LLMs and agents and so on. It's all about context. So for any decision or any evaluation that you want to do about the vulnerability or anything in your environment from a cybersecurity point of view, you need the full context and you need the right precise context that is relevant for the question you're trying to answer with the agent, right? So this means that behind the agent itself, that is something that you probably can create a script very quickly. You need to have very complex, scalable, maintainable, data retrieval systems that basically help you bring the right context at the right time. And even then you need to optimize those. So cost is the second dimension. That's why I'm saying that we need to optimize. So LLM inference is fairly expensive, and especially vulnerability management. As you know, there's normally, as soon as you're at minimum size, you have millions of vulnerabilities open, and then things start to get very expensive and volumes are really high. So I've been working with companies with tens of millions of vulnerability open for a while. And if you want to investigate each one of them, even if it costs you a few cents, how often are you going to do that? And it gets really expensive. So cost optimization comes into the picture. And this is without thinking about the longer term, let's say, maintenance and quality that you want to sustain on these and evaluation of these systems, right? So that's a complete different thing of you will need to have your data system very organized, you know, basically the provenance of the data. You might be audited. So you might want to show an auditor, this CV had this severity back then, we evaluated it like that, and that's why we didn't address it within the critical SLA, right? So there's a lot of requirements that come down the line as you start building that are a lot harder. And I mean, we can get a lot deeper into the LLM and agent side if you wish.
And you said all of that without, and we haven't even covered the skill set part yet as well. I mean, person who's going to maintain this at your end.
Yeah, absolutely. So this is something I've had quite a few experiences of this, and this what I loved about joining this podcast and this topic, because I encountered a lot of CISOs and a lot of security teams that basically jumped into building, and there's a lot of things down the line that become tricky, right? So I remember one of the biggest stock exchanges in the world. One of the security engineers in their team had built basically a few scripts in his laptop that was doing a very specific task. And then the challenge became when that person tried to leave the company, right? So he was the only one that understood what was happening, could even maintain that system, and he was just running from his laptop. He would trigger it once a day. It was a very, very complicated situation, right? So you need the skills that generally, based on at least my experience, security teams do not have machine learning engineers, software engineers, data engineers that can build this type of systems, but they have this very hacker mentality in general that can get a lot of things done, which is great. But as a big enterprise, you need to think a little bit deeper about like, okay, how does that play out in a year of this system? So I'm going to be investing a lot of time, a lot of money on inference, on building new systems. I'm going to become dependent on this system, but what is year 2 or 3 of this system in my organization?
Because there's this whole conversation about now these days, obviously there is a whole CSPM CNAP market, but there's also now everyone has an MCP as well. It's like, it's almost just, it's like the Oprah moment of you get money, everyone gets money. It's like everyone gets an MCP. Would that make this any easier?
So the way I see MCP is great for basically having agents that are driven by humans. So if you can, MCP is great for basically plugging in a lot of things. It needs to be properly secure, by the way. There's a lot of discussions around that and how to secure it. But you can have basically an agent that you trigger something and then through MCP does something and comes back. But that's scaled with the number of people operating on these agents, right? Or using these agents, right? But for a lot of the cybersecurity tasks, I think systems need to be autonomous and do work when you are sleeping, right? And this is our case, right? So we provide hundreds of thousands of agents to our customers. And that means that MCP there has a hard time scaling and actually meeting the demands that you have, right? So you're going to be looking potentially concurrently into many thousands or tens of thousands or more, basically loading context, and MCP, that's one of the challenges. You need to optimize it as a data retrieval system, I believe. And that's basically where MCP starts to have a few issues.
I mean, you just mentioned retrieval augmentation as well. I mean, so maybe let's just start building one. So the people actually, I don't know, I would want to call it out that a lot of people who may have been using AI for some time, they always do what you said. You start with a few small scripts. You've been drinking that Kool-Aid that OpenAI has been sharing, and I suddenly feel that, I already have my vulnerabilities in Claude from my CNAP or CSPM. I already have the data that I need. All I need to do is just put some kind of a wrapping of OpenAI or something. But maybe we should probably start diving into what does it look like from an architecture perspective. If someone was to build an AI first cloud vulnerability management in their team, what would that look like as from an architecture perspective in their practice?
Yeah, that's very good. So there's some key components that I will define here. So the first one is sort of your data, where the context is, and basically how do you build that context? So data ingestion pipelines. Yeah. So let's say we start with vulnerability management. Let's say we will need to have, I don't know, GCP, Azure, and AWS critical context that we want to have. Let's say that this is, I don't know, VPC security groups and EC2 instance definitions, right? That would be one part. You need to ingest that daily. And let's say, and then you will have your CNAP, your CSPM that will give you additional context in terms of misconfigurations and vulnerabilities that were found in your infrastructure, right? So there you will have sort of like a list of vulnerabilities and misconfigurations that were found. You will have the context to try to analyze them. So this needs to be, it sounds easy, but this needs to be a system that works at scale, that has good performance, that actually keeps the data very organized. So you can go back and look on specific data. What is the data that you had to do the evaluation? So there's a lot of requirements there that are not that easy. And that's where the data engineering skills come into play, right? So that's not core to a security engineer, let's say, or security team. So once you have that, it's just the data that allows you to then do your agents, right? And then depending how you want to run this, but you will need to have some sort of environment or infrastructure for executing agents. So you can write a script, like a small LangGraph agent, that is very simple, that looks into this context and then makes a decision, right? But you will want to run these thousands, if not hundreds of thousands of times per day, or based on your cycle, right? But you will need to run it a lot. So you need, again, an execution platform, whatever it is. This could be APIs, this could be job or workflow based. There could be many different things. But this is, again, another key component that needs to be maintained, reliable. You need to be patching it over time. So there's a lot of things there. And then there's the whole thing of like evaluation of this agent that you just built. You build this agent, great. Works. Week 1, it works phenomenally. The week 2, suddenly you start seeing that the results are not great. How do you know of your 100,000, how many are off? How can you evaluate? Are you going to sample some of them and just make a decision? No, you need to have basically machine learning pipelines that actually evaluate how the agents are doing, that do some metrics on them. And then you need to be on top of those metrics. And then every week or every day, look at those metrics and see how that works. That's more of machine learning skill set, right? So that's sort of, I would say, the MVP for an enterprise, right? So we're a company that's already, if you have a security team of a certain size, the amount of data instances you're going to have or devices, let's say, is going to be certain that there's some requirements in there. Yeah.
Interesting, because as you said that, a lot of example that I've heard from people is more around, I don't know, I take a CNAP or a CSPM provided log, I get a collection of those log, I use Claude or GPT or Gemini or whatever to go, hey, find me patterns out of this, which one should be a priority. But what you're saying is a lot more than that, because are you building a system that is repeatable, or are you building a one-off script that you run every time you feel like, actually, I'm going to work on Claude today and see what happens?
Yeah, but exactly. So that is the challenge, right? So, and that's the decision. So if you want to do something that is holistic, that really looks at all your vulnerabilities and help you assess the situation holistically, you need to look at all of them. You cannot say like, oh, during my 8 hours today as a security engineer, I run the script on 3,000 of them, and this is what I got. What about the other 900,000 that you didn't look at, right? So at that scale, the problems are really big in terms of numbers. On the other side, that doesn't mean that you cannot build some, let's say, investigation tools to help yourself. So as a security engineer, I think this is an area that a lot can be built, right? So there is more of like helping you investigate things, help you bring context, evaluate context, look at different type of things, and then kind of do assessment. So that can definitely be done, but it's a very different approach in a way. So one of them is like overnight, a lot of stuff gets done for you and you look at the results and then continue from there. And then the other is like, you're still looking at the million vulnerabilities every day and trying to figure out which is the one. But it's a lot harder, and I don't think it's as holistic and properly attacking the problem, let's say.
Do you have an example of an enterprise where they tried doing this and maybe using an internal agent framework and perhaps it broke down?
Yes, we have talked with multiple, and some of them very big enterprises. Basically, A lot of enterprises nowadays have pushed for bringing AI and have introduced some sort of framework and trying to provide that to development teams. There's one specifically that they push a framework forward, but they build it on top of one of the existing frameworks, LangGraph and LangChain, but they limited it in some capabilities. Already LangGraph and LangChain is a framework that has a lot of abstraction layers, so they added more layers of abstraction on top. So the amount of issues that they encounter is tremendous. And actually, they are now, their security teams are telling us like, yeah, this doesn't work. We cannot build the agents that we need with this. And this is just from the, let's say, building the frameworks and the tools for being able to build that little script that we talk about. And then those companies are now looking outside, seeing, okay, this requires a lot more than we thought. How can we get help on this one?
So actually, for people who may not know what LangChain and LangGraph is,
Yeah.
what is that, and what does that have to do with what we're building?
Yes, very good question. So LangChain and LangGraph are basically the same creators. Are two libraries that were among the first ones and very popular for building initially basically any LLM workflow, let's say, with LangChain, and then LangGraph introduced basically a lot more agentic features. You can use a tool to look at certain data. You can create an agent that sort of like goes into a loop, calling tools and making decisions, and can provide an output. So some of the most popular frameworks. There's a lot of frameworks out there, and this is another topic I wrote about this. Agentic frameworks for scaling, it's really hard. It's getting better, but I think there's no one framework that really solves all the problems that you need. In the end, you need to have a combination of multiple frameworks for you to be able to actually do everything you need in a cost-efficient and effective manner, let's say. And this, again, more of the challenge of it's a new technology, it's up and coming, still a lot being developed, and there's a lot of hurdles there too.
Yeah, I mean, there's a lot to unpack there, but which I would love to get into, because maybe if I just take a step deeper into this. I'm a CISO. I have a CNAB,
Yeah.
and obviously I have a huge push from my CTO and the organization to just 10x the use of AI in your organization. Where am I starting? Am I starting with LangChain, or am I starting with deciding Gemini? Where am I starting in this particular process? What am I needing from a tool, data, team kind of perspective?
Yeah, it's very, very good. So I think that basically figuring out what is a problem or a specific space where you want to look into within vulnerability management. I mean, prioritization is one of the ones that comes first, but there's a lot of them that you could be looking at. And so I think the idea is first, figure out what's the context that, let's say, a security analyst would need to make a decision. This is how we think, that is, try to follow the human process into decision making. Because nowadays, I mean, we work with a lot of very senior security engineers, and they tell us basically the situation, what data they look at, how do they make a decision. And I think that's probably a good place to start. And generally, at least in security engineers that I work with, they have very established processes. They know exactly what they want at which point in time. So trying to figure out if you can collect all the data together or query it from different systems, but basically have a way to get that data. Then obviously you need to have the skills from the software engineering side of things, of being able to build these agents, being able to deploy them in some environment. I would say those are the absolute bare minimum to start, but this will just give you an understanding of the potential of the technology, then making it sustainable, like maintainable, longer term, reliable, that you can improve it, that you can, let's say, trust the risk posture of your organization based on the system. That is a bit more down the line, and it takes a lot more of the components that we talked earlier.
Interesting. Wait, so because you mentioned a software engineer, a security engineer,
Yeah,
and you also have like a data engineer, and you already have like the two skill sets that normally don't exist in security normally. Security usually just has a security engineer. So if I'm a CISO who's trying to go down this path, I already have to consider either borrowing a data engineer from or a software engineer from another team to be able to bring this over. And because a lot of people may oversimplify this, because a lot of people have been using console for ChatGPT or Claude or whatever.
Yeah.
But we're not referring to that when you talk about tooling from an agent perspective, right?
No.
What's like like if I were to just use an example of, I don't know, man, I'm on AWS. I have logs coming out from CloudTrail that I sent into S3 bucket, which is collecting my CloudTrail. Like, how am I piping that into this with a software engineer and a data engineer? What are they doing?
Yeah. So that's the part, right? So this is basically another source, right? So a log that comes through some sort of stream is something that you basically need to pipe into some sort of, either you process it on the fly and decide, I want to look into this log deeper or not. So you can have some sort of, let's say, a Kafka stream, and then you pick it up, look at it, makes sense, then queue it into another system to look deeper into it. Maybe there's certain combination of attributes that you can basically with the agent evaluate. Again, logs are a tough use case for LLMs because of the inference cost, right? So remember that the number of logs entries is just huge.
Yeah.
So the cost is something to be very careful about in this situation. So then that will be evaluating it, putting it into some queue for some other system that you build to be looking into it. And then this could be, again, it could be as simple as a Lambda, let's say, and then you will be calling, let's say, Bedrock to do the inference, right? This is kind of like sort of the absolute minimum if you want to look at logs, right? But in general, you could have some sort of system like that eventually, after the agent looks into it, it could alert you about certain conditions again. But this is it's just icing on the cake. This is just the very basic, right? So how do you explain to your CISO, why did you raise a red flag and alarm on that event that the Lambda notified you about? So the first thing you will want to go is look at, did the LLM actually make the right decision? What data was the LLM looking at? Where did the data come from? And a lot of other things like that observability requirement, you need to build it into the system. It's not that it's going to happen automatically, that everything is going to be there, right? So there's all of these things that are sort of afterthoughts that in the case of the LLMs, and especially in terms of security, that is such an important topic. You need to be very sharp there.
Yeah, we haven't even gone to the LangChain part yet. Like this is like before any of the LangChain came in.
Yeah, and exactly that Lambda in the end could be, let's say, running a small agent, right? So that's where you could have a LangChain or LangGraph small agent that is doing some sort of calling to Bedrock, doing the LLM. And again, in there's a whole world that we didn't talk about, but it's like the prompts. How do you make sure that the results are consistent? So this log coming in tomorrow or in a week, I want to have the same behavior, right? I verified it today, works great. What about next week? What about the week after, right? This variability, and this is the whole, in a way, hallucination problem of LLMs. That requires a lot of careful tuning of the prompts, testing, evaluation, constant evaluation, not just like at development time you evaluate it and it's fine. It's just down the line you need to sort of be evaluating the outputs to see that everything is kind of like still in line. And then as you introduce changes, let's imagine that you say you were looking at VPCs and security groups, and now you add load balancers and a web application firewall. Suddenly the prompt could be that it's not good enough anymore, and the LLM is confused and starts failing left and right. So you need to detect that and be able to react and change it. Ideally not in production, on a separate environment where we are running these things before putting it into production, right? So there's a lot of complexity. At first sounds easy, but if you want to build it maintainable, sustainable for long term, and be able to rely on, is very tricky. And I have this thing about relying on, and why I keep repeating on it, is because I work with some public big tech companies that have a lot of audit requirements, especially around cybersecurity insurance. And basically, they need to be able to provide to the auditors a snapshot in time of the CVEs that they detected, the full context that they had in there, and what were the decisions they made to make sure that they are according to their SLAs. And there's a lot of things that change over time. Like, for example, CV severities change. So sometimes 3 months ago, it was a medium, and today it's a critical because something was discovered in this recent CVE, right? So this kind of thing, you need to be able as a security team to explain why you are within SLAs and your cybersecurity insurance premium should not go up. That requires a level of organization and basically having your house in order to be able to pull that up quickly and explain to auditors.
Man, it's like, this is just to reduce the false positive.
Exactly.
I haven't even gotten to the point of I'm going to take an action. This is like, I don't even know the timeline I would take, but the few things that I noted over there was if you are someone who's thinking about building this, and if you go down the path of, you need to think about the continuous stream of logs that's going to add to the cost of token, where you put this, how you put this, and how you use this, that's going to add that in. Second, then is the skill set that you're going to look at from am I using cloud for inference? Am I doing it locally? If I do locally or if I do it in cloud, the cost associated with it, but also what are some of the logistics around it? Would you go for Lambda with a lang graph with where the data is streamed to once you've decided what you're sending? Once you've done that, you have to now you have a prompt lifecycle that you need to manage, a CVE lifecycle you need to manage, a threat intel lifecycle you need to manage. Obviously, I'm not trying to deter people from this. Like, if people want to experiment, that's why we are in technology. You should definitely go give it a shot. But if they were starting to go, you know what, great Santiago, but I'm still very determined. What are some of the 2 or 3 things that they must consider to have if they wanted to go down this path? Because I imagine not every enterprise is, I guess, at that stage, but there might be people who are much smaller startups or whatever, or wherever, like the scale-ups I'm thinking about, who are very build-first kind of mentality. What would be the top 3 things you think they should have to if they want to go down this path?
Yeah, very good question. First of all, if anyone out there, any CISO tries to build internally and wants help, I'm happy to provide it completely, like not trying to sell you Maze, but this is a complex topic and we're happy to help others on this. So I think in my mind, like connecting this with the CTO discussion, what I would do, to be honest, is basically look at the problem you want to address and then go to your CTO with basically an understanding of the problem you're trying to attack, saying like, look, this problem, we're spending this amount of time, or is increasing our risk significantly in these conditions. In order to build a system, we want to build a system that does these things, kind of mention a few of the key components, and then describe the staffing or the requirements that you will have in there, right? And then you will have a minimum setup. And then this could be very minimal, right? So you could start very small with 1 or 2 engineers that had the right skill sets or right combination of skill sets, right? But I think that's what I would start with in order to try to build this. Going from having the problem and trying to solve it with scripts, I feel down the line, it hurts more than helps, because it's a false perception that you got a hang on it. And then over time, things will get a lot harder. So that's what I would say, what are key 3 things that I would look into to really address the problem and solve it in some way. And as I said, happy to help, like completely send my question my way, really.
Would I need some kind of a data lake or something as well while I'm doing this?
Yeah, I think that's the whole data retrieval system, right? So as I mentioned at the beginning, so I worked on pipelines for ingestion, vulnerability management, and asset inventory specifically across multiple cybersecurity tools. And the best strategy, in my opinion, there is having a data lake at a certain scale, right? Where you have all of your vulnerabilities, all of your assets, all of the context that you need, organized per day, and then the agents will basically be looking into that one to look on, okay, we're running the investigation today. What's the context today? Let's run with that context and so on.
Damn. So we have an execution framework, execution fabric, the data lake. Then I think you mentioned evals earlier as well. You kind of need to have figured out how you're going to evaluate this. Maybe you want to change cloud component as well.
Oh yeah, that's a key one actually. You touched there on a very important topic. In our experience, changing from one model to the next version or to another model. So if you go from Claude 4 to 4.5, Claude Sonnet 4 to 4.5, or Gemini 2 to 2.5, the difference is significant. So if we are evaluating the outputs, the moment you change the model, generally, you're going to see that all your metrics suddenly go a little bit out of whack, and you need to try to understand, is it good, is it bad, how can I mitigate that, right? And that's the whole part of the machine learning, let's say, ops or pipelines, that is evaluating like a percentage of the execution, having some metrics that you trust. Those metrics change, by the way. You cannot have metrics from now until end of next year. You will need to be changing over time because eventually the metrics become less useful. You need to monitor those as you do changes, make sure that the changes are in the right direction, the metrics are moving the way you want. And that's a whole effort this is probably the one of the hardest skills in there that we're describing. So the software engineer, lead engineer, I think those two are a little bit more easy to get. But this one of machine learning, I remember one big enterprise that I talked in the past, and they were like the build versus buy. And they told us like, yeah, we have only one machine learning engineer in the engineering team, but I don't get time from him to help us. And it was just that situation. It's like, those skills are really hard. It's not that you're going to ramp it up in 2 weeks or a month.
Yeah, I mean, I guess because there's more and more sounding like the AI agent is not just another feature. It's more like a separate pipeline,
Mm.
like it's by itself.
Yes.
Even if you were to do it
Yeah.
yourself or a vendor doing it.
Yeah. Yes, I do agree with that. I think it's a completely new methodology, especially on the evaluation, on the prompt changes, on the building the tools for them. It's quite different than any previous, let's say, machine learning technology.
Because you probably maintain the entire ecosystem. You have you to. I mean, we
Yeah.
kind of touched on one pipeline of
Yeah.
this. We didn't even mention about everything else you may want to do in security as well. It's just like a
Yeah.
tiny slither of what cybersecurity is, and
Correct.
we're going. Oh wait, if you're just doing that as an AI, maybe you have a dedicated
Yeah.
team for it. But so does that mean now the way people measure vulnerability management should change as well based on this? Like if you're using intelligence layer on top of it, what's the right unit to measure what a good vulnerability management metric would be, especially for people who are like we're going towards
Mm.
2026 and many people are already
Yeah.
considering, hey, what's an uplift for AI that I should be doing? What's your recommendation there?
That's a very good question. Yeah, to be honest, I think there's a few things that I think are changing in terms of how we measure performance for teams. Basically, in a way, we have in all terms, we have a lot more productivity in
Yeah,
terms of like potentially we'll be able to go through a lot more than we were before if we have agents.
yeah,
So I think then the question becomes looking at the impact, let's say the reduction on risk or the improvement on the things that we have in their control. One of the key things that we hear over and over and now for me years and years is that we cannot be on top of all the vulnerabilities. There's so many, right? So that perception of, okay, we're on top of them. Yes, this tool actually reviewed a bunch of them. These are false positives. These other ones, we evaluate them. These are the critical ones. These are taken care of. So that perception of the team of being on top of things, this is one of the key metrics that we get from security teams when we talk with them. That is when they see what Maze will bring to the picture, right? That's precisely the value that we're looking for. It's like, okay, you got it. You got it. This means it's a lot more productivity. It's a lot more understanding and control, let's say, on your risk profile in a way. I think that's one of the ones. It's hard to measure, and it depends how your organization measures it specifically. But yeah, I think that's one of the key ones.
would there be any change to the whole mean time to resolution MTTR or criticals being closed, or I don't know,
Yeah,
engineering hour invested? Is there metrics around that as well that we
100%.
should consider?
Yeah, 100%. And I think there, the interesting thing is that I think organizations need to start to get used to having false positive processes. Like how, when you say you find false positive, how do you declare a false positive? How you properly document why it was a false positive? And yes, I mean, MTTR will definitely be changed. The number of criticals you're going to get probably is going to change significantly too. We talk with a lot of organizations that are like, we are in the zero criticals club, which is great. But what about the high that is actually critical, but is misclassified and it doesn't understand your context, right? So those are actually criticals that are hidden, that are a lot more important. So I think yes, MTTR is one of them, but also the understanding the real severity and the real impact in your infrastructure, and then how are you managing those?
Yeah.
I think that's very important.
Yeah. Would you say when you guys are building the agent and basically using that for some of your customers, was there something that surprised you out of curiosity? Like, I don't know, like a human-like insight, or was there more mistakes? What was like the surprising thing out of it?
Yeah, there's a lot of along the way. There's been a lot of this. So in some of the earlier versions of the product, one of the things that like the first thing that surprised me, let's say, is how the discussions felt. So it was basically we had some sort of initial prototypes where there would be different roles on different agents, and they would be discussing with each other about specific topics. And I remember this one where we have one of the roles was the project manager, and the project manager told the others, "Let's get back on on the topic, because we were going off track, and our goal is to do this specific investigation." But they were like talking about specific technical details of something else. I love that one. It's one of my all-time favorite. I think that there's been others where, and another key point for me was when I realized the depth that the agents are getting to in a single, let's say, run was more than a single staff security engineer would know. So they would be touching such deep topics and multiple of them in one run, that security engineers will not be able to assess it, like manually assess it, right? So we do a lot of manual assessment and labeling, and this is from very senior engineers. And then some of them will be like, yeah, those two I understand, but that one I need to learn because I don't know exactly what is the right way of doing that.
Oh yeah, because I think so that's a good one, because to your point, I also have been in a trap where I would start asking about a vulnerability to, I don't know, one of the models that I'm working with, and I'll completely go on a different rabbit hole, because as a curious technical person, you want to understand the depth of why and
Yeah,
how and everything that is around that one particular
yeah,
problem. But to what the example that you called out, it may be taking you off track for what you're actually trying to
yes,
do versus what you
yes,
should be doing.
yes. Yeah, so this is definitely a key problem. And again, this is another part of building the systems, right? All of that conversation off track, you pay for it.
Yeah.
So you don't want them to do that.
Yeah.
So
Token,
there's
that's
a lot of
token being spent for like it's like I'm using
exactly.
the
Let me
internet
go
for cat
look at
videos.
yeah, let me go look at more logs and retrieve more data because I'm just curious about it. It's like,
Yeah,
no, please stay on topic.
yeah, that's a good point as well, because as much it's like every request you make to your LLM model is actually costing you money as well.
Sure.
So it's not the same as that. Hey, it's only a few cents, right? Like
Yeah.
there's, because you go down a rabbit hole, keep asking questions, and suddenly you spend like, I don't know, thousands of tokens, and you're like, oh, by the way, we
Yep.
can't use AI anymore for the rest of the month because we just went over our quota.
Yeah. Yeah. This is one of the key things, right? So understanding the costs and getting to them is like I talk with a lot of engineers that are building similar systems, and very often, and this is like outside of Maze, like interviewing and other sources, but helping other people, very often they want to put a lot of data, send a lot of data to the LLM to review. And that has a lot of problems aside from cost. But one of the main one is like you need to think, how does that scale? So if
Mm.
I'm going to fill the context and I'm going to do 5 requests and then get an output, and I need to run this 100,000 times a day, is significant money. So this is one of the areas that I think is definitely not intuitive of how much tokens are required.
Yeah, and people don't even talk about it. I think it's like
No.
a software. You can just keep asking question unless there's a guardrail
Yeah.
to, hey, stop spending money now. It's like there's no way to just stop
Yeah.
that. I think I was talking to someone. Actually, this is a maybe a good segue into the whole multi-agent world as well, because people
Mhm.
don't even have one agent these days. They believe in that whole idea of, especially the ones who are building. And to be fair,
Mhm.
fair to them, that's why you're scaling it. This multi-agent, like if you have a fleet
Yeah.
of security agents, I would even think governance, like we are obviously a security team building a fleet of security agents. What would governance be like in that particular context? 'Cause we spoke about like, what does it look like without security? What's the security component in there, and how does that scale with multi
Yeah.
agents?
Yeah, that's and this is a massive challenge, right? So what those agents are allowed to do,
Yeah.
what are the actions they can take themselves, which other agents they can communicate with, and always like think about the unintended consequence that what is kind of like the worst case scenario. And we have here like a very small anecdote, but we had very early on some agents investigating a vulnerability on an image, and what they figured out, because they didn't know the current date,
Mm.
they were only we're not putting the date into the prompt, so the agents were thinking that it was the last time they were trained.
Oh.
So they suddenly look at this vulnerability on this image, they look at the data and they say, look, this image was just published, it's in the future, so it was just published, so it very likely will go to production. And we had a bug on the credentials that they were assuming to do that investigation, and they could actually delete. So they themselves, this was a multi-agent early on, they went and deleted that image from the repository because they thought this is clearly a very severe vulnerability, which was correct.
Yeah.
But please don't delete it. So this is the whole challenge around, and this again, if you think about US company having multiple teams building agents on the security domain, and each one having different tools, like there's unintended consequences of these interactions that
Yeah.
I
Yeah.
think that's where guardrails come into place, your policies come into place. And we haven't talked yet about where your data goes. So you need to have your own data policies, right? Are you fine your security group going to Bedrock? Or you find them going to, I don't know, XAI or to another provider, right? So the best models change over time. There's more expensive, cheaper. So defining your policies up front to understand what is allowed, what is not allowed in terms of where the data can go, what data can go where. Maybe some data can go to some place, other more sensitive data cannot. So I think this is part of the whole governance that it needs to be thought through basically ahead of time to make sure that you don't have surprises down the line.
Actually, because we spoke about the AI agent pipeline, how different would that be in a multi-agent world? Is it the Lambda function with the LangChain talking to another Lambda function with the LangChain?
Yes, correct. So not specific Lambdas. You could do it with Lambdas, but basically there would be multiple agents deployed in places, and then they could receive a message from another agent saying, "Hey,
Like an
I'm
API
this
call?
agent." Yeah, it could be an API call. It could be a message in a queue. It could be an event that is triggered. It could be many things, right? Or it could be multiple things, right? Imagine that, say, you have a specific event that it says, okay, impossible travel, trying to log in on failed authentication and suddenly succeed. So someone's trying to log in and suddenly logs in from London, from New York, from Russia, and suddenly succeeds from North Korea.
Yeah.
What you want to do in there is probably trigger an investigation immediately. So it could be that is an event that goes into a bus, and then there's multiple agents that go into like, okay, let me go look at the logs in different places, and then collect all that information or that intelligence somewhere else. This is not so much vulnerability management; it's more like incident response, but that's kind of the general mechanism. Like together, those agents they are aware of other agents, and they are aware that they can ask questions. Or maybe you can have more like Oracle type agents where you have an agent that is an expert on, I don't know, VPC security. So when another agent has a question about VPC security, could ask that agent specific question about VPC security, and then the VPC security agent is the only one that has full context and understanding of certain things, and is prompted in a specific way, right? So that's where the agents start to interact with each other based on expertise and what they need, right?
Yeah. And I guess to what you said as well, now your quote unquote, your security fleet is now a mix of, I won't say living and breathing, but very interactive API calls just being made across the board.
Yes. I think that's where, to be honest, that seems like a likely future in terms of having semi-autonomous systems that do a minimum amount of decision making and especially report on what they find out. I think the deep dive into looking at the logs, understanding a lot of details, I think a lot of it can be automated. And that output from the agents could be then consumed by a human, for example. So in a way, it's not that you're replacing the human, you're just giving them the smarter work in a way. And then over time, basically, it's going to be more and more higher level that they can start resolving that.
So talking about the future as well, because I feel there's obviously, there is the two sides to the whole AI narrative. One is the productivity side, and one is the, hey, I'm going to make my revenue making applications way more AI integrated. And that's different for different people. A lot of people put this particular conversation in that productivity camp as, if I give AI access to my security engineers, they would be able to revolutionize whatever they do, automate. So what part of because the more I speak to you, the more I realize, and this is kind of across the board, when everything that I'm finding myself in that same corner as well. No company out there, unless you're a cybersecurity company, you would be building a productivity AI security thing for as a product, because you're literally just building a product inside your company if you were to go down this path of doing this. But what components are something that they can do with AI, which is very much in that realm for, okay, I'm not building a product. I'm sure there's better examples than making my email less angry. What have you seen some examples in the security space that people can do for AI productivity, out of curiosity?
That's a very good question. So one small nugget there, I think there's some companies that are building these products internally. And I think certain companies, it makes sense that they build it internally. Certain companies that are extremely good at software, that build a lot of their software internally, that are like, I think those companies will continue to build all of these products internally. So I think those are hard to change. It's just, I think there's a massive gap, and there's a massive amount of companies that should really think this is their core investment that they want to do, and basically think thoroughly about the long tail. But thinking about things that companies could basically build outside of the main things, what I would say is some of those evaluations of those agents that look at outputs from different places and then either notify or do some sort of alerting or kind of some initial assessment of things. I think those agents are probably easier to do in a way, and again, provide more productivity let's say, automations in a way.
Right. Because I think there's this theory also, the fact that, like, for example, a vendor would be able to fill that gap for, hey, I would win the AI system, but I want you to maintain an internal knowledge source for your RAG,
Oh yeah.
you have a RAG pipeline, you have vector databases, you have your own maybe MCP connections to talk to certain specific things.
Yeah.
You don't want to give them direct network access. You only want to give them API access.
Yeah.
So in my mind, we're almost turning security companies into like security teams into like these guardians of knowledge sources, for lack of a better word. And you still end up, even irrespective of whether you make the choice to buy or to build, I feel like that's kind of where we're leaning towards, because that's where it makes more sense for it to be the time well spent, for lack of a better word.
Yeah, I think that makes sense. I think that I agree with you on this one. It's probably a time well spent in that direction. Building those type of tools it can really help unblock in certain situations. The key there is, and you touched a topic there that is really key to me. That is RAG. So RAG works in our experience works great for documentation type of data, but when I want to know some specific technical requirement of part of the infrastructure, RAG systems are really tricky because they are probabilistic and they might leave that one critical detail outside. So, or they might, for example, one specific example that I had in my mind is version numbers.
Yep.
So we built a RAG system with a lot of data, and one of the questions that in one of the agents asked was specifically about version numbers. RAG system was terrible at giving us the precise, complete list of those version numbers, right? So you need to be careful about what questions are you going to ask your RAG system. It could be great, for example, to imagine you have engineering documentation inside of your RAG system, and you want to try to assess the importance of a specific system. That might be great, because you will basically retrieve context around specific description of a system. But for security and when you want to make decisions that are critical, you need to make sure that you have all the version numbers. You need to make sure that you have the full security group description, let's say, in the context of the agent that is going to make the decision. And if you take it from a RAG system, you might not just get the whole thing. Yeah, this again, lessons along the way that we learn.
Interesting. So if you were to, hopefully at this point in time, people are more aware of what actually takes it to be building AI first vulnerability management. If they were to buy a solution in this particular space, how would someone be evaluating something like this? Because I guess at this point in time, everyone is calling out AI, and no offense, it's also like hard to judge the signal from the noise.
Yeah.
What do you see as someone who's been working in this particular space quite deeply? Is something people can do to use to evaluate solutions in this particular space? Where is it's an AI band-aid versus AI first?
Yeah, absolutely. I mean, for me, that is if the way we think about it is, if tomorrow Bedrock is down, like if tomorrow your inference product is down, is your product working? For an LLM first company, there's no product. The product will not do anything today. For a company that sprinkle LLM features on top of, the main logic will still be there. The main decision making will still be there. Your scanner will still produce results. It's just you will not have this one feature that maybe you click the button and something happens and goes on LLM, right? But that's sort of like sprinkling the LLM on top. And that's just like one of the basic ones, but it's hard to know sometimes. So the way I would think about it is like, how much, so the decision making that is happening, can I understand that it comes from specific, maybe sometimes extremely complex rules that are in the background? Or is it something that truly looks at unstructured contextual information and then makes decisions based on that? And are the recommendations always A, B, C, or D? Or is sometimes coming up with recommendations that we're like, that's really smart, I never thought about it. But yes, that is true, because that detail here tells you that could be a potential solution, right? So I think those are some of the indicators of like different price when something is built LLM first, let's say.
Wait, so does that mean vendors who are AI first would, like, or the main work that they're doing is they're building the scaffolding around to what you said, even though the core of the product may be built from an LLM, but the scaffolding around, obviously it's not like this is software, it's not going to die on you. It's more like certain feature. If Bedrock was down tomorrow, the product would still work, but it may not be able to make inference calls.
Exactly. So that is the thing. So your agents will not run. So let's say you're an LLM first company. and an agent wants to look into some data, when it goes to Bedrock, there won't be no response. There won't be the answer to your question, right? So, and that's why, again, we rely on inference on our hyperscalers that we trust with our databases.
Yeah.
So chances of that happening is rare, even though we had a recent event, as you know. But that's basically, it's a dependency of the system, and it's a critical one. While in other products that are sprinkling it on top, maybe a feature will just disable itself because coming to inference today.
Yeah. Well, do you find people who are trying to build this, for lack of a better word, first generation enterprise agents, what are some of the architectural mistakes they're doing that you see?
I walk you through a few. The first thing that I mentioned, those were all like critical learnings that we had. I mean, RAG, for example, what I mentioned, where and how
that RAG is a
to use
good one as
RAG
well.
it's a critical one. I think there is this whole discussion around how do you evaluate, and there's this vibe evaluation that is, you look at the results, looks great. You're running it, let's say 1,000 times, and you look at 10 of them, they all look great. But this is no way of evaluating LLM systems. And this is one of the key, I would say, one of the most important mistakes one can do, that is trust that vibe feeling that you get without having validations across the bigger data sets. This is the whole building evals in your system, right? So having robust systems that evaluate it from many different angles and always similar type of metrics, so you can just compare across runs, compare across changes, and so on. Sometimes you will be surprised how a small change in a prompt just throws off specific reasoning that just never goes where you want it to go from then going forward. I think this is, if I have to put, this is probably number one. Like not thinking about evaluation and basically being very careful how you evaluate to make sure that every change is one step forward and not 2 steps back. So that's one of them. You mentioned RAG. I think the context is another one. So the not thinking about how much data you're going to be putting in there and the cost associated with it. I talked with a few founders on the, let's say, log processing side of things, and these are some of the challenges that many of them encounter. It's a lot, as many of the companies out there know. You kind of basically run a LLM through your SIEM throughput.
Yeah, and maybe just on the eval thing, because we obviously gave an example of the whole eval, and we also spoke about the fact that potential future for security engineers who are working with these AI first vulnerability management companies or vendors would be to have better evals on their end to because they would obviously have internally, they would have a lot of inference as well. What is eval just a I don't know, a soft piece of code, or what is it?
Very good question. Very good question. So an eval, short for evaluation, you cannot think of it as a test for a specific output. Let's say you ask an agent to do a task, it came back with an output. And then you can ask a question, is that output concise enough and provides sufficient rationale, right? And you will have specific, and you will have specific examples of this is good rationale, this is a concise answer, this is not good rationale, this is not a concise answer, right? You run that prompt against the output of your agent, and then the answer will be true, false, let's say. If you run that at scale, you will see, okay, 90% of our agents provide good rationale in their evaluation, right? Then you introduce a change, you change your agent, you run this again, and suddenly 70% of the agents are providing good rationale. So that's something for us to go look into, because that prompt change probably improved some other metric, but this one metric suddenly is not there. And this is very unpredictable, I would say. You gain a bit of predictability with experience, but generally it's very hard to predict, and especially changes from model to model. You will do this with one model, will be 70%, next model gives you 30%. It's didn't change anything. No prompt change. I just changed the model. So these are all of the things about evaluating that I think is critical to understand how you test these systems, because they're all probabilistic, right? It's not deterministic like previous systems.
Because the reason I was asking this is because these days, the whole notion is that the vulnerabilities are found a lot more quicker as well, especially if you have intelligence layer. Should the way people approach SLA models for vulnerability patching from a timeline perspective just shrinking? Do we need to reevaluate that? Because in my mind, the eval was an interesting one because you say you are using, I don't know, just some kind of intelligence layer, you get an answer, But the complaint that the cloud security industry used to have is that, hey, we don't respond to alerts for 4 weeks. It's a long time. If the volume is now increased, the response time should change as well, and the detection time should change as
100%.
well. How are you seeing, or what do you think people should do to change that, and how should they approach that?
Huge questions, and one of the reasons why I started this company. So if you look at the metrics over the last few years in terms of time to exploit, number of vulnerabilities published, so everything is moving against security teams. So there's more and more vulnerabilities being published now. With NIST having the issues and now having multiple sources, it gets a bit more tricky, right? Even, but also the time to exploit. I think it was Mandiant that published that now they see it exploited before it's actually published as a new CV, right? So everything move against you. So I think definitely there needs to be more automation to have those assessments at least of, is this really addressing us? And this I think, in my vision, where cybersecurity will end up going is in that direction, saying you get intelligence feed signals that tell you we're seeing this exploit on this type of software. We don't know of a CV that they're exploiting, but we see these botnets using that specific type of messages. And then you just go and say, okay, where do I have that specific software installed? Kind of check if I have that version that has been published, and then kind of do an initial assessment of, is that really critical, right? And I think that's where things need to be moving, because it's really tricky otherwise. As you said, the time to respond is negative, basically. You need to be responded before the CV is published.
Wait, is there an unpopular opinion about AI and security that you think will age in the next 3 to 5 years?
That is a good one. So there's this whole race to basically to super intelligence, to LLMs that are basically super intelligent. I think extremely well-crafted agents with sufficient context in certain scenarios, in application specific, they're indistinguishable from super intelligent AI. It's not super intelligent across the board, but in specific niches, we're going to start seeing that this agent has all the contents. And again, an agent is not an agent anymore. It's an agent with an army of sub-agents and an army of tools behind them, right? But they retrieve so much context and understanding for making the decision that is going to be very hard to differentiate from super intelligent AI on that specific use case. And I think that we're starting to see that already in terms of certain doctor assessments. I think it's coming in a lot of areas, in some papers, some research that is being done by agents. So I think that's basically, with the intelligence we have nowadays, is probably sufficient to build these extremely complex agents. So that's why, like, the idea of super intelligence, I'm saying that it's going to age is we don't need to get there to see something that is truly surprising in terms of how smart it comes across, right? So everyone is waiting for that moment when there's this one model that is super intelligent. Well-crafted agents with sufficient context are going to get there on specific use cases before we get to that one model.
So we'll see glimpses of super intelligence agent everywhere.
Yes, I do think so.
Terminator.
I do think so.
No, dude, that's all the technical questions I had. I've got a few fun questions for you as well. First one, what do you spend most time on when you're not trying to solve all the AI first vulnerability management problems of the world?
I have 3 kids, 3 small kids, below the age of 6. That consumes every single second that I'm not in my laptop, probably. So that's where I spend most of my time. Yes, outside of work. Yeah.
That's a fair point. Second question, what is something that you're proud of that is not on your social media?
Oh, wow. That's a good one. Very good. No one is aware of my kids.
Oh, fair. There you go.
Starting a company with 3 small kids, it took a lot, and it takes a lot daily. I'm quite proud of how me and, again, my family as a whole, because this is not a me thing, it's a whole family effort in a way. We managed to basically get here in a sustainable way and basically being able to move at the pace that we've moved as a company. I'm quite proud of that. I think we did great as a family and as a company, and being able to have those balances. And again, this is not just me, but it's across the company. But I'm proud that we managed to build a company that allows for that.
That's awesome, man. Thank you for sharing that. Final question, what's your favorite cuisine or restaurant that you can share with us?
Oh, so I'm originally from Argentina. So I love a good steakhouse, ideally an Argentine steakhouse that cooks things slightly different than other places. That's what I generally love. So anything where there's an Argentine restaurant, I'll be happy to join for dinner anytime.
Wait, what's the difference between a regular steak and an Argentine steak?
It depends, but in some areas of Argentina, the barbecue is very slow. It's a very low temperature. So it will take sometimes literally 2 hours or 3 hours to just cook a steak or a piece of meat. So we have slightly different ways of doing asado is the name that we call it.
Yeah.
And yes, when you get a place that do it right, it's truly something else.
Wow. I look forward to trying one of these then. Because I've had Argentine steak before, but I never realized the difference in terms of different, I guess, the region of Argentina they may come from. They may make it differently as well.
Yeah, exactly. Yeah, and I think there's also a lot of restaurants have used the marketing of Argentina to sell steaks, and there's others where the person grilling is Argentine or has been trained on that, and that's a difference.
Okay. Now, good to know. Thank you for sharing that. Well, that's all the questions I had for you, man. But where can people connect with you to learn more about what you're doing at Maze and what other things you're working on?
Yeah, LinkedIn, Twitter, I would say are the main two. Yes, and then obviously through Maze, just contact us through any channel. Happy to help anyone trying to build this internally. It's not easy. Please take the help if you can.
I appreciate that. I'll put that in the show notes as well. But thank you so much for tuning in for this, man. I appreciate you spending your time for this, and for everyone else tuning in, thank you so much for tuning us in the episode. I'll see you next one. Thank you for listening or watching this episode of Cloud Security Podcast. This was brought to you by techriot.io. If you are enjoying episodes on cloud security, you can find more episodes like these on cloudsecuritypodcast.tv, our website, or on social media platforms like YouTube, LinkedIn, and Apple Spotify. In case you are interested in learning about AI security as well, do check out our sister podcast called AI Security Podcast, which is available on YouTube, LinkedIn, Spotify, Apple as well, where we talk to other CISOs and practitioners about what's the latest in the world of AI security. Finally, if you're after a newsletter, it just gives you top news and insight from all the experts we talk to at Cloud Security Podcast. You can check that out on cloudsecurity.newsletter.com. I'll see you in the next episode. Peace.